Okay, so we have 5.1 part 1. So this is actually the beginning of the second chapter of trig. And this first part of our notes today has a whole bunch of formulas. And most of these are formulas that we've used already. We have the reciprocal identities, like sine is 1 over cosecant. We have the quotient identities, such as tangent is sine over cosine. We have the 3 Pythagorean identities. We've used those already. We've used the cofunction identities. Now, most of the times we don't use these for proofs. And then we have what are called even and odd identities, and those deal with graphs, and we'll get to those. But again, most of what we have used so far when we've worked with proofs are the first section right up here. So we're actually going to do some more proofs this unit. We're also going to be using these formulas to help us solve for different trig functions. So you also have access to a formula sheet for this unit, and it's called the Fundamental Trig Identities. And again, all of the ones that are in the box on your notes for today are also on this formula sheet, plus all the other formula sheets we're going to be learning about this unit. And there's quite a few. We have sum and difference formulas, double angle formulas, power reducing formulas. And there's a second page, half angle formulas, product to sum, sum to product, and law of sines and law of cosines. And we'll actually end the unit with the law of sines and law of cosines. So we actually will be getting through all of these formulas. So we're going to start with using some of our easier formulas that we've already used to help us solve for different trig functions. So looking at example 1, it says use the values secant is equal to -3/2 and tangent is positive to find the values of all 6 trig functions. So first I want to figure out what quadrant we're working in. So remember our mnemonic device, all students take calculus, and that helps us figure out what quadrant we're working in. So if tangent is positive and secant is negative, I'm looking for the quadrant where tangent is positive and the other functions would be negative. So that means I'm in the third quadrant. Now I could draw a right triangle, or we could use our formulas from up above. So I'm going to use the formulas here. First off, I'm going to make a list. So I'm going to list my 6 trig functions: sine of u, cosine of u, tangent of u, cosecant of u, secant of u, and cotangent of u. And I'm going to list the ones I know already. So I already know, I'm going to switch colors. So I already know that secant is -3/2. And I know cosine, because that's a reciprocal, would be -2/3. I also know that tangent is positive. So therefore, cotangent would be positive. Sine and cosecant would be negative because tangent is the only function positive in the third quadrant. Okay, so I'm going to pick a formula. So I know cosine. I want to pick a formula that's going to give us another trig function. So I can't use this one up here because I already figured out cosecant, but I have a formula right here. Sine squared plus cosine squared equals 1. So I'm going to write that one down. Sine squared plus cosine squared equals 1. Okay, so I know cosine, so I'm going to plug -2/3 in for cosine. And I'm going to solve, plus, this should be a plus sign. -2 cubed, -2/3 squared is 4/9. So I'm going to subtract 4/9 from both sides. One minus 4/9, that would be 9/9 minus 4/9. So that would be 5/9. And I'm going to take the square root. So sine, now I already know sine has to be negative, so I don't have to worry about the plus or minus. It would be √5/3. So √5/3. So cosecant would be the reciprocal of that, 3 over root 5, or negative 3 root 5 over 5. And tangent, so I can use my quotient identities. Tangent is sine over cosine. So sine over cosine, the 3's would cancel. That would be positive root 5 over 2. And cotangent, I would flip that, 2 over root 5, and we can write that as 2 root 5 over 5. Okay, so let's try number 2. This time we're given tangent and secant. So I'm going to make a list again. I've got sine, and this is x we're using, cosine, tangent, cosecant, secant, and cotangent. Okay, so I know tangent is 7 over 24. I know secant is negative 25 over 24. So right away I can get my reciprocals. Cosine would be negative 24 over 25. Cotangent would be 24 over 7. So the quadrant we'd be working in, all students take calculus. We're looking for the quadrant where tangent is positive and cosine is negative. That would be in the third quadrant again. So sine would also be negative, and so would cosecant. So again, you can make a right triangle and solve, or we could use our formulas. So if I need sine, but I know tangent and cosine, I can use the quotient identity that tangent equals sine over cosine. So I'm going to plug in 7 over 24 for tangent, sine over cosine, negative 24 over 25. So if I cross multiply, 7 over 24 times negative 24 over 25, the 24's cancel, so that's negative 7 over 25. So I'm going to write that in up here. The reciprocal would be negative 25 over 7. Okay, on to number 3. Here we have tangent is 2 and sine is negative. So I'm going to make my list again. Sine, cosine, tangent, cosecant, secant, cotangent. Okay, so let's figure out what quadrant we're working in. All students take calculus. So we're looking, again, tangent is positive, sine is negative, so we've got to be in the third quadrant again. Okay, so I know tangent is 2. Cotangent would be 1/2. All of the others would be negative. Okay, so I know tangent, and I want to find something else. So I can use, if you look at your formula sheet, I can use the Pythagorean identity that 1 plus tangent squared equals secant squared. So I'm going to plug in 2 for tangent. That would give me 1 plus 4, so 5. Take the square root. Secant is root 5. And I know the answer has to be negative. So I can get the reciprocal by flipping that, 1 over root 5, which is negative root 5 over 5. Okay, last thing I need now, I need sine. So I'm going to use the property that tangent is equal to sine over cosine and plug in what I know. If tangent is 2, I don't know sine, but I know cosine is negative root 5 over 5. So if I cross multiply, that gives me negative 2 root 5 over 5. And if I get the reciprocal for cosecant, I get negative 5 over 2 root 5. So that simplifies, if I multiply by root 5, that would be negative 5 root 5 over 5 times 2, so that would be 10. So negative root 5 over 2. Okay, another thing we can do with these properties is we can simplify function. This is very similar to a proof because we're using formulas to plug in so we can simplify. A couple things I try to do is you can factor, you can multiply. Another thing I usually try to do is convert everything to sine and cosine. Those are just tricks you can use to help you try to simplify. So for example, if I look at number 4, I have two terms here. Terms are always separated with a plus or a minus. So both of these terms have a sign in common. So I'm going to factor out that sign. I would be left with cosine squared minus 1. Now, if you go to your formula sheet and you look at the Pythagorean identities, you'll see that there's a sine squared plus cosine squared equals 1 there. If I manipulate this, and if I move things around, I can subtract this 1 over and subtract the sine over, and I can write this as cosine squared minus 1 equals negative sine squared. So I just moved things around in that formula, which means that I can substitute for the cosine squared minus 1 a negative sine squared. So if I bring down that sine of x out in front, I can multiply these together. That now means there's 3 of them, so negative sine cubed of x. So you're done when you've gotten it down to one trig function, or as simplified as you can. So if we look at number 5, this one's actually already been factored. There's always a couple things you could try to do. So I could multiply the sine through. I could try converting everything to sine and cosine. Sometimes there's more than one way to do these problems. Let me try converting to sine and cosine. So I already have the sines in here, but I have a cosecant. If we look at our reciprocal identities, cosecant is equal to 1 over sine. So I'm just going to replace that with a 1 over sine. Okay, so it's already factored, but I could probably multiply it. If I multiply this sine through, sine times 1 over sine is 1, minus sine times sine is sine squared. Okay, now whenever I see a squared in a problem, I think about Pythagorean identities. I'm going to use the concept that sine squared plus cosine squared equals 1. And if I manipulate this a little bit, if I move this sine squared to the other side, that gives me cosine squared equals 1 minus sine squared, which is exactly what we have here. So we can write, instead of 1 minus sine squared, I can write cosine squared. So your goal when you simplify is to get down to one term or one trig function. So we've got both here. We've got one term and one trig function. Okay, let's go to number 6. So 6, I can't factor anything, so technically that's one term because we're multiplying. Let's see, I could try to convert to sine and cosine. So let's do that. Let's look at our formula sheet. Secant is equal to 1 over cosine. So I'm going to try that. Sine's okay, but tangent is sine over cosine. Now right away I just made myself a problem here because we always learn that we can't have a fraction in a fraction, which I just did. So I'm going to fix this. I'm going to multiply the top and bottom by the reciprocal. So this disappears, right? And these sines disappear. So this is just cosine. All of this just gives me cosine. So I'm left with 1 over cosine times cosine. And these cosines now cancel. And my final answer is 1. So I've got one term And one trig function, well, we actually got rid of the trig functions. There's none left. Okay, last one, number 7. I've got cosine squared over 1 minus sine. So everything's already in sine and cosine. There's nothing to multiply, but I could probably factor this if I tried or did something. I don't know. We'll have to look and see. I do see a squared. So what I said before, whenever I see a square, I usually think of the Pythagorean identities. And the one with the sine and cosine is going to be the one we're going to use. Sine squared. I'm going to use y for this one because that's our variable. Plus cosine squared equals 1. So I'm going to solve for cosine squared since that's what I want to convert. So I'm going to move this sine squared over to the other side. And I'm going to plug this in. 1 minus sine squared y. Now it looks like we made it worse for ourselves, but I actually got this now down to one trig function. And if I look at the top, I have a difference of 2 squares. So I can actually factor the top now. So I did make things a little better for myself. If I had an x squared minus y squared, remember when we do a difference of squares, it's x plus y times x minus y. So this is the same thing. This is 1 plus sine times 1 minus sine over 1 minus sine. And if we look at this, 1 minus sine, we can cancel those right out. And I'm left with 1 plus sine of y. There's nothing else we can do with that. We can't factor that. We can't multiply it. It's already in terms of sine and cosine. And we can't simplify it any further. So these are definitely tricky. We're going to keep practicing these over the next couple sections of the book. So this is kind of like a beginning stage of doing these. So take your time, rewatch it, rework the problems. You will get better at them, and use your formula sheet because that has a lot of the keys that you're going to need to help you simplify. And when we start doing proofs, it's going to make things a lot easier.